Dear friends, this is the lecture number 9 of current electricity. So, in the previous lecture, we have discussed about KCL, KVL, Kirchhoff's laws, and in this lecture, we will discuss about Wheatstone bridge and its applications. So, let's discuss Wheatstone bridge. You all have listened this two words, Wheatstone bridge. Where you have listened? You have listened in the previous chapter. In previous chapter, while solving the circuits of capacitors, you have applied the Wheatstone bridge condition without understanding anything. What is Wheatstone bridge? You have just applied. I had told just to apply like this. C1 by C2 is equal to C3 by C4, ballast condition, then the middle capacitor cancelled. But today we'll elaborately discuss what is Wheatstone bridge, but not with capacitor, with resistor we'll discuss today. This theory part is in your syllabus. So this one we'll discuss today. So what is Wheatstone bridge? 4 resistors connected like this. Now see, 4 resistors. They are connected like this. P, Q, R, S. P, Q, R, S are not the name of resistors. They are the resistances of the resistors. Its resistance P, its resistance Q, its resistance R, its resistance S. These are the name of the resistors. They are connected like this, and between it, from this point to this point, I am connecting one galvanometer G. G is also the resistance of a galvanometer. Don't misunderstand that G is the name of the galvanometer I have given. No, G is the resistance of the galvanometer, and PQRS are the resistances of the 4 resistors. And how we supply current? We will supply current by this shell, EMF E. So it is like this. This whole arrangement is called as Wheatstone bridge. This whole arrangement. When anything connected like this, maybe capacitor here. Also, one device you will listen at the end of the 12th class, that is called diode, semiconductor diode. Sometimes also diodes are connected here. That is also called Wheatstone bridge. Any type of arrangement like this called as Wheatstone bridge. In day-to-day life, in many electronic circuit, in electrical circuits also, this Wheatstone bridge arrangement is done. So now let's discuss about this Wheatstone bridge. So these are the 4 resistors. I am just giving the name of this A, B, C, D. I am just naming like this. Okay. So cell provide current. First let's discuss how is the current distribution. This is very important. Let's discuss the current distribution. If you understand this current distribution, then you can able to solve also your one book example. As well as also in book exercise, one question is there, your 3.9 exercise question. You can also solve that one easily if you understand the current distribution of this Wheatstone bridge. So here, I current start from this. So let's start I current from here. When it reaches at this point, now junction came according to KCL, Kirchhoff's current law. It will divide. Now this current here this current, suppose this side current is going I1, this side how much current will go? I minus I1. Understand? I minus I1. Why I am taking I minus I1? I am taking I minus I1 not to increase number of variables. I can take I2 here, but always keep this habit not to increase number of variables. I had told you in my previous lecture. Not to increase number of variables. If you increase the number of variables, you will face the problem. You have to write accordingly that much number of equations to solve the circuit. So I minus I1. This I1 current go to B point. Then here again junction come. So this side current is going IG. I'm just writing the symbol IG. So this side current will go I1 minus IG. Don't confuse about this. I am writing a small g. Okay. But galvanometer capital G resistance. Don't confuse about this. IG is just a symbol. Okay. Don't give it more importance. It's just a symbol. I am writing IG. I can write I symbol as capital G, but it is easy to write small g. Okay. Then to D. Now see the point D. Current comes IG here like this. Current comes I minus I1 like this. Mark here. IG comes like this, I minus I1 comes like this, and the total current goes to this side, and total current becomes here I minus I1 plus IG. I hope you understood how it is. I minus I1 current come, IG current come, total current become I minus I1 plus IG. Then now the current here. See the junction C. You see the junction C, current comes I1 minus IG, here I minus I1 plus IG, then the total current becomes here IG, I. Now you add them. If you add this and this, total current become I. This is the current distribution of Kirchhoff's of Wheatstone test. In this way you will do the current distribution. And if a little doubt you have, you again back this video and again play it and try to understand it. Listen time and again, you listen this and try to understand how is the current distribution. Still I am telling you, for sometime I current comes, here I1 goes, here I minus I1, then here I1 current goes to B point, again junction come, IG pass like this, here I minus I1 come, here IG, here I minus I1, net current goes I minus I1 plus IG, and here I1 current, IG pass like this, that becomes I1 minus IG. That current comes, this current comes, and total current becomes I. You add them. IG cancel, I1 cancel, only I remain. I current enter, I current comes out. Based on conservation of a charge, how much current will enter, that much current obviously will come out. So this is the current distribution. I hope everybody understood. It's a very important part. Current distribution in KVL circuits is very important. Any question is coming to your mind after seeing this? Current distribution? Any question coming to your mind? You can pause the video here and think the question for 2 minutes. Any doubt is coming from here? What current distribution I have done? You ask yourself, think what question can be possible here, where I have done anything I have taken just like that. Any question coming to your mind? Okay. Now I think you pause the video and you thought the question, what is coming to your mind. If the question coming to your mind, it's good. If it's not coming to your mind, then I am telling what question generally comes to the mind of the students after this current distribution. Frequently asked questions students always ask. Those who have analytical brain, those who understand the physics going to the depth, they always ask this question. This IG current, I am taking I1 current, then from B to D I have got the current. Some students ask the question, sir, why you are not taking from D to B? Because this is the common line. Current can come from B to D. Also, if A to D, this I minus I1 current come. Why I minus I1 current will not divide like this? Why this current will divide? Why this current will divide IG and I minus I1? This is B point. Why this current will divide like this? I1 minus IG. Okay. Why this current will not divide that I minus I1 current? Why this will not divide like this? This is the question. Means this is the B point. Why question asked here? Why general students ask this question? Why you are, sir, why you are taking the current from B to D? why you are not taking the current from D to B? Frequently asked question. Think the answer. What will the answer? Now think it. If this type of question is not coming to your mind, and now I told you the question, you think the answer. What happened? Okay. So I'm telling you the answer. I hope you thought this answer now. You now check whether you thought the correct answer or not. B to D I got the current means B is at higher potential. This is the important concept of this Wheatstone bridge. That is the main concept of the Wheatstone bridge. Try to understand. B to D I got the current. That means I am taking B at higher potential, D at lower potential. If you are telling to take the current from D to B, means you want to tell D is at higher potential and B is at lower potential. Then you are telling, sorry, you take the current from D to B, because then D is at higher potential. Actually, as I am not taking any particular resistance, I am just taking the symbols. So it is difficult to know at which point potential is more, because I am not taking any particular value of the resistances, also no value here. So it is difficult to tell at which point potential is more, at B or at D. So I am just I am taking like that. Okay, at B potential is more, at D potential is less. Just I am taking like that. If you tell no sir, you take the current from D to B, no problem, you are not wrong. You can take the current from D to B, because you are telling sir, you take the potential of D higher, but I am taking potential of B higher. If I take potential of D higher, also no problem. You can bring the current from B to D, or also you can bring the current from D to B, no problem. You can do like that. It will not be a mistake. Why the mistake is not coming? Because actually in this Wheatstone bridge, what we'll do, we'll discuss about balanced Wheatstone bridge. And when the bridge is said to be balanced, when potential of B and potential of D will be same. Balanced Wheatstone bridge, it is said to be balanced when potential of B is equal to potential of D. That means no current passes through this line. No current passes through this line. Ig is equal to 0. No current passes through this line. So it not matters whether you are taking B higher potential or D higher potential, because applying special case will do potential of B is the same as potential of D, for which in this derivation it doesn't matter. Now you understood? I am taking the current from B to D. You can take the current also from D to B, no problem, because after some time we will do potential of B and D same, and we will make the current 0. So it doesn't matter which potential you are taking more. Okay, so now let's come to the part. Let's now derive the balanced condition of Wheatstone bridge, which always comes in exam. In exam question will come like this: write KCL, KVL, and derive the balanced condition of a Wheatstone bridge. 5 marks question will come in exam. So now let's derive it. So this is the figure. To derive, let's apply KVL. KVL in which loop? A, B, C, A, B, D, A. In this loop now you apply KVL. A, B, D, A. This loop. Okay. Now apply KVL. So this is the P is the resistance. I am going along. Minus I1P. Then now come again I am going along. So minus IGG. Okay, now I come like this to D. Then I am going opposite. Means plus. I minus I1 whole into R is equal to 0. So this is the equation number 1. Apply KVL in ABDA. Taking you apply KVL in BCDB. This loop B, C, D, B. Apply KVL now in this loop BCDB. So B to C you are coming along. So minus I1 minus Ig into Q. Then you are going C to D opposite, means plus I minus I1 plus Ig into S. Then D to B, you are going opposite, so plus Igg is equal to 0. So equation number 2. So these are the two equations we apply KVL. But I just before told you, this bridge is said to be balanced if VB is equal to VD and Ig is equal to 0. We will discuss this bridge in balanced condition. Now let's see, applying balanced condition, Ig is equal to 0. If Ig is equal to 0, in balanced condition, if Ig is equal to 0, when the bridge is balanced, then what happens to equation 1 and equation 2? Now let's see, equation 1 minus I1p, this I is 0, this remains, plus I minus I1 into R is equal to 0. So I1p is equal to I minus I1 into R. So this is the equation number 3, which comes from equation number 1. Understand? Okay. Then from equation 2 becomes what happens in balanced condition when I is 0. Let's see, minus I1q, which I is 0, plus I minus I1 into S. Then this term is completely 0. It is 0. So implies that I1q is equal to I minus I1 into S. Okay, so this is the equation number 4. Divide equation 3 and equation 4. Now let's divide. If we divide equation 3 and 4, what will get here? Let's see, what will get here? LHS by LHS, P by Q, RHS by RHS, R by S. This is the balanced condition of Wheatstone bridge. What you have applied, you see, P by Q, R by S. You have applied this balanced condition in capacitor. Also, you can apply the same balanced condition in resistor to solve circuits, to find effective resistance of the complicated circuits. I hope you will understand this balanced condition now. Okay, so now let's discuss one question related to this balanced condition. This derivation comes as a 5 marks question in exam. I told you what question it will ask. I am using this one. What question will come in the board exams? Question come, write KCL, write KVL, derive balanced condition. Okay, so this will come as 1 mark. This will come as 1 mark. Balanced condition derived, this will come as, this may come as half mark. Distribution depends on different marking scheme. This comes as 3 marks. Okay, now it will become how much? 3 plus half, it will become 4 marks. But I told you it comes in exam as 5 marks question, but it totally become 4. Another tail will be attached here. In every derivation, one tail question is always attached there, which creates the problem to students. You will not understand the tail question. Okay, so now let's see. What tail question will be asked here? That's also 1 mark. What tail question can be attached here? Now let's discuss. First question, tail question what will be asked here. When Wheatstone bridge is said to be most sensitive? When Wheatstone bridge is said to be most sensitive, remember, most sensitive gives you accurate measurement. When it's said to be most sensitive, if all the 4 resistances are equal, if all the 4 resistances are equal, 5 ohm, 5 ohm, 5 ohm, 5 ohm, that is called most sensitive. So your answer will be, I am repeating the question, when Wheatstone bridge is said to be most sensitive. Your answer is, if all the 4 resistances are equal. Then another question, also another tail question may be asked here. Two questions are there from Wheatstone, two tail questions. Another question what? This is very important, what I am going to tell. This one is very important, always comes in exam. Also comes individual as 1 mark question in the question paper. If cell and galvanometer position are interchanged, what happens to balanced condition? If cell and galvanometer position are interchanged, what happens to balanced condition? This comes as 1 mark question. Is there a change in balanced condition if cell and galvanometer are interchanged? The answer is, what the answer? You can pause the video here, you think the answer, then again you play the video. Okay, I am telling you the answer. I hope you thought it. Whether balance condition will change or not, yes or no. If your answer is coming no change in balance condition, then you are right. No change in balance condition. Balance condition is like that. You see, if you can understand, I am drawing the figure again. I am drawing the figure again. This is P, this is P, Q, R, S. So this is now the cell, and this is now the galvanometer. This is now the galvanometer. Okay. So what happens to the balance condition here? See, what initially you are taking from the cell you are dividing P, Q, R, S from both sides of the galvanometer. P, Q, R, S from the cell point you are dividing. You see the cell point is here. Your cell point is here. From the cell point you are dividing P, then crossing the galvanometer Q, then RS. This is the cell point. Now you see, here is the galvanometer connected. So between these two. So if it is connected between these two, means also between these two. Here is the galvanometer. I can also connect the galvanometer there. I can also connect the galvanometer there. You see, this is the galvanometer. You see, I am drawing the diagram like this. Okay, I am drawing the diagram like this. Say from the cell point Q by S, P by R. Q by S, P by R. Q by S, P by R. Understand? So what is coming? PS is equal to QR. And what was your condition? Your condition from this, P by Q is equal to R by S. This is also PS equal to RQ. And doubt here? So galvanometer was here, but I just take the galvanometer at that point. Just I am taking the wire above it. In the crossing position, you know in class 10 the symbols. When wire go another wire on the another wire without touching it, the symbol is like this. Okay, galvanometer is here. Then Q by S, P by R. Here P by Q, R by S. Always you cross the galvanometer. Cross the galvanometer. Q by S, P by R. Same thing. This is very important question. If cell and galvanometer position are interchanged, what happens to the balanced condition? Answer is no. I hope everybody understand. So this is all about the Wheatstone piece, but numerical type small questions will come in exam. To find effective resistance, you can able to try this question. Okay, this is the question you can try. Very simple question. 5 ohm, 10 ohm, 3 ohm, 6 ohm. Here is 7 ohm. These are the 2 points. A, B, C, D. Find the effective resistance of the circuit. Some students, what they do, when 7 ohm is still connected, but they always think 5 and 10 are connected in series. Now they are not connected in series because in between them one wire is connected. Series means what? I have told you series connection means when one resistor is directly connected to another resistor. Directly connected to another resistor. That is series connection. But here, if another wire is going like this is suppose R3. Now both are not in series. If one wire will go like this, then they are not in series. Remember, series means R1 is directly connected to active, then this is series. But if one wire is coming between them, then they are not in series. Remember, okay? So this are not in series. These two are not in series because another wire is there. Then this wire, how it is connected? 10 and 6, they are not in series because another wire is going like this. Difficult to solve, but if you use Wheatstone balanced condition, immediately the question will be solved. Check whether the balanced condition satisfy or not. You have to check first whether it is satisfy or not. So 5, 10, find the ratio P by Q is 2. P by Q is half. P by Q, this is half. R by S. R by S, this is also half. P by Q, R by S, half. So it satisfies balanced condition. You satisfy no current passes to this 7 ohm. You just redraw the figure. You redraw the figure again. First I am erasing here 7. It's very simple circuit. 5, 10 series connection, 3, 6 series connection. And what is the effective resistance? This total become 15. This total become 9. Then 15 into 9 by 15 plus 9. Parallel formula. R1 R2 by R1 plus R2. Okay. Then answer. Don't expect I will solve, I will deny. That's your work. Okay. So this is all about the Wheatstone bridge. Balanced condition and how one mark questions will come, how two numerical will come, how derivatives will come. Thank you, and in the next lecture I will discuss about its application. Thank you.